So these control valves, they act as actuators, receiving control from a controller, receiving signals. So these control valves act as actuators by receiving signals from a controller. So this controller can either be a standalone electronic or pneumatic controller, or else it can be a software based controller in a distributed control system. So now what this controller does is it measures the actual process signals, that is called as a process variables, from a transmitter. Say in case of a flow measurement, flow transmitters measures the actual flow inside a process pipeline. So this is the process variable. Now as a user I am going to enter a desired set point. Say for example, I need to control or maintain the flow at 10 liters per hour. So I enter this value as my set point. So now what the controller does is it compares the set point with the existing process variable. So if the flow is more than the required flow rate, it regulates or it reduces the flow by closing the control valve. And in the opposite case, it is going to open the control valve more such that more flow can be allowed through it. So this is the actual function of a control valve. So the control valve can either adjust the flow rate as well as adjust the pressure of the output flow. So now we'll look into the basic components present in a control valve. So we can classify these components majorly or predominantly into four categories. So for the first is the valve body. So this valve body, it is the main housing which has the internal components which control the flow. So we call it as the trim. So if you look at the diagram on the left hand side, the trim has a plug and a cage. Right? So the bottom part is the valve body. It has inside a cage and a plug. So this plug actually regulates the flow. So based upon the opening clearance provided between the plug and the valve seat, the flow rate is decided, right? And now in order to control the movement of this plug, we have a actuator. So it is the topmost part in the control valve. So we are going to give a signal from the controller, right? From the controller we are going to give a signal which in turn converts the electronic signals into a pneumatic value. So this pneumatic pressure is going to be applied to a actuator. So this is in case of a pneumatic valve. So this actuator, it has a diaphragm. So mostly it has a diaphragm attached to a spring, right? So this spring will maintain the valve in a fixed position. So once we apply the pressure, the air pressure, pneumatic pressure, the diaphragm is either going to move up or down based upon the direction in which the pneumatic supply is provided. So if it is a pneumatic supply is provided at the top, the diaphragm will push the valve down. So this actuator, it is connected to the valve body through a stem, right? So it is the center part. As you can see, there is an actuator stem and a valve stem. So these two stems are coupled together, right? So as the actuator moves, the stem is going to move, and again which in turn moves the valve plug. So this valve plug regulates the flow. Now this another major component in the control valve is a positioner. So now we are giving a signal to the actuator. So what happens? The actuator is going to move either up or down. So this supply pressure is going to be continuously provided to the actuator, right? So we need to keep it in a particular fixed position. So for that we have a unit called as a positioner, right? So this positioner gets the input feedback from the coupling, right? So as the valve moves, this feedback is given to the positioner, which in turn maintains the or provides fix the valve in a particular position without fluctuating it. So this positioner, it enhances the accuracy of the valve by providing feedback as well as the fine tuning the actuator's position. So finally, we are going to see about how to optimize the control valve, right? So the first thing in optimizing a control valve is actuator sizing, right? Choosing the right actuator size for the applications. So if you see here, so the final topic which you are going to see is the control valve optimization strategies. So how we are going to optimize the performance of a control valve. So the first thing is optimizing the size of actuator, right? So choosing the right actuator size for the given application. So if there is a, we need to handle regulation of fluids with high pressures, then we need a large actuator size. Right? So that is the first step, choosing the right actuator size for a given process parameter. Second one is fine tuning the positioner settings. So we have to adjust the positioner settings such that it can properly respond to the valve feedback. So from the feedback link, we are going to connect the positioner feedback and the valve movement, right? So this feedback should be properly ensured to correct the valve movement and the signal to the actuator. And third one is the regular maintenance of control valve. So periodically you have to perform, clean the moving parts, check the pneumatic tubings, lubricating, replacing the gland packings with, over a period of time. So these regular maintenance are necessary to optimize the working of control valve. And we have to continuously monitor the valve performance, right? Whether there is any stiction or whether there is any hunting, whether there are any leakages in the pneumatic tubings. So all these can lead to abnormalities in the control valve performance. So if we follow all these steps, we can ensure that the control valve is optimized for the particular application, and there are no mechanical losses as well as any disturbances in the process parameters. So to conclude my presentation, I would say that control valves are very critical part in industrial automation systems. So these control valves, they enable the precise regulation of fluid flow, so which in turn controls other process parameters like flow, pressure, level as well as temperature. So understanding their functioning, maintenance and how to diagnose or troubleshoot the controllers, it is crucial for efficient as well as a reliable process control. Thank you.